Hello everyone and welcome back to the Intermediate Algebra video lectures. Today we are going to be covering the first part of factoring. Now factoring is going to be a bit of a process, so we are going to go in stages and learn how to factor. And today's lecture is going to be on a topic called common factors and a factoring technique called factoring by grouping. So first of all, what is factoring? Factoring is basically distribution backwards. So factoring is the same as dividing and writing the quotient and the divisor as a product. You have factored regular numbers before. For example, what two numbers multiply to 12? Well, you can write 12 as 4 times 3. The act of writing 12 as 4 times 3 is called factoring. So in terms of polynomials, what you're doing is you're basically writing it as a polynomial as a product of two other polynomials. So two numbers that are being multiplied are called factors of the product. So for example, 4 and 3 are both factors of 12. So this same concept applies to both whole numbers and to polynomials. So back in the last chapter, when you distributed factors, their product was the polynomial. So factoring is the process of writing a polynomial as a product of two other smaller polynomials. It's basically reverse distribution. And because it's basically reverse distribution, you can always check your answer using distribution. So for example, if you have the binomials x minus 3 times x plus 1, if you were to fully distribute this, you would get x squared minus 2x minus 3 after you do all of the foiling and all of the combining like terms. Factoring is the process of taking a polynomial like x squared minus 2x minus 3 and writing it as the product of x minus 3 times x plus 1. So because factoring is the reverse of distribution, you can always check your answer by using distribution. You could always distribute your answer and see if you get the exact same polynomial back. If you do get the exact same polynomial back, that means you did it correctly. If you do not get the exact same polynomial back, that means you did something wrong in your factoring. Now, just like regular numbers, not every number had factors other than 1 in itself. For example, 17. The only two numbers that multiply to 17 are 1 and itself. So 17 is what is called a prime number. It cannot be factored other than 1 in itself. So a prime number is a number whose only factors are 1 in itself. That same concept applies to polynomials as well. There are going to be some polynomials that can't be factored. So if a polynomial cannot be written as the product of two other polynomials, it is called a prime polynomial. And it just means that it cannot be factored. The only factors are 1 and itself. We're not going to see too many of those yet, but when we do eventually see them, I will point them out. And I will point out why they are prime polynomials. Now, I will say that factoring is going to be a bit of a process. There's going to be a lot to learn in order to be able to successfully factor. So we're going to go through this in pieces and in stages. One of the things that you should always look for in any sort of factoring problem is something called a greatest common factor, which we call a GCF just for short. So a GCF happens when every single term in the polynomial has something in common. And I'm talking every single term in that polynomial without exception. They all have something in common. For example, maybe all of the coefficients and the constant are all divisible by the same number. Maybe every single term contains the same variable. Maybe to different powers, but maybe every single term contains an x in it or a y in it. When this happens, when every single term in a polynomial is either divisible by the same number or all contains the same variable, you have a greatest common factor, or GCF. So here's what GCFs are going to look like in polynomials. There's going to be two different types. There's going to be numeric GCFs and variable GCFs. So GCF should be something that you always look for first. No matter what section in this chapter we're in, no matter what we're doing, you should always take a look for greatest common factors first. So to look for greatest common factors, you're going to ask yourself, do all of the terms in this polynomial have a common factor? all of the terms without exception. So you should ask yourself, are all of the coefficients divisible by the same number? If they are, you have a numeric GCF. You should also ask, do all of the terms contain the same variable? And if so, what is the highest power of x that occurs in all of them? We're going to get to what that means when we actually see one, but you should just take a look at, okay, do all of the terms contain an x in it? Now, if every single term in the polynomial has a common factor, then there is a greatest common factor. And the nice thing about greatest common factors is that they can be factored out. So they can be written themselves as products. So GCFs, when you factor them out, they are written as multiples or multipliers out front. And the factored polynomial is then written in parentheses directly next to it. Now, we're just going to be focusing on greatest common factors today. We're not going to be getting into more factoring techniques. We're going to leave those for later videos. So I will say from there, after you factor out the GCF, most of the time the polynomial may be able to be factored further. We're going to get more into that and explore that more later in other videos. That is another video for another day. But what we're going to do with each of these is we're going to identify the greatest common factor in each of these. So you should ask yourself two things. Are all of the numbers divisible by the same thing? And do all of the terms contain the same variable? Now, I will say that if all of the terms contain the same variable, that means that the greatest common factor is going to be the lowest power of that variable that appears in the polynomial. So, looking at 8x minus 2. So, take a look at 8 and 2. What are both 8 and 2 divisible by? Well, 8 and 2 are both divisible by 2. All we're doing on this slide is identifying the GCF, so we're not going to worry about factoring anything out right now. We're just working on identifying the GCF. I'm going to show you how to factor out the GCFs, and then we'll get some practice with that. But in this first example, each of the terms is divisible by 2. So because every single term is divisible by 2, there is a greatest common factor of 2. Now, there are no variable GCFs here because there's an x in this term but not in this term, so the greatest common factor is just 2. Now, if you look at the next one up on the top right, the 2x cubed minus x squared plus 3x. If you take a look at the numbers in front, we have 2, we have -1, and then we have 3. So unfortunately, not all of the numbers are divisible by the same thing. In fact, all of the coefficients are prime numbers, so there's no numeric GCF here. But if you take a look at each of the terms, every single term in this polynomial all contains the same variable x. So because every single term contains the same variable, that means we have a variable GCF. When you have a variable GCF, the exponent on that GCF is the lowest power of x that appears across the whole polynomial. So we have x to the third, x squared, and x to the power 1. So the lowest power of x that appears in the polynomial is 1, and there's an x to the power 1 in every single one of these terms. So your greatest common factor is going to be x to the power 1. Now, I will say that there are times when there are more than one GCF. You can have 2 or more GCFs in a polynomial. So looking at this next one, 9x squared plus 27x plus 3. Let's take a look at the numbers in front. We've got 9, we've got 27, and we have 3. What is the largest number that goes into all 3 of those? Well, all 3 of those are divisible by 3. So there is at least a numeric GCF of 3. Now looking at this next one for the x squared, oh, by the way, for this last one, we have an x in this term, but there's no x in this term. So because not every single term contains the same variable, there is no variable GCF. So in this case, the GCF was just 3. I promise on this slide there's going to be one example that has multiple GCFs, so just stay tuned for that. However, looking at the next one, we have x squared plus 3x. So if you take a look at the numbers in front, we have 1 and 3. And the only thing they're both divisible by is 1, which doesn't count as a GCF. So there is no numeric GCF here. However, both of the terms contain an x, so there is a variable GCF. When every single one of the terms has the same variable, the exponent on your GCF is the lowest power of x that appears. So since the lowest power of x that appears is 1, your GCF is x to the power 1. And then for this last one, for the 7x to the fourth plus 14x cubed minus 21x squared. This is an example where there's more than one GCF. So yes, you can have 2 or more GCFs. Let's take a look at the numbers, 7, 14, and negative 21. What are all of these divisible by? Well, every single one of these is divisible by 7. So there is a numeric GCF of 7. And in addition to that, every single one of these terms contains the same variable. Every single one of these terms contains a variable x. So there is also, in addition to this 7, a variable GCF. Now, the power on your GCF is the lowest power of x that appears in the polynomial. So the lowest power of x that appears here is x to the power 2. That means that there is an x to the power 2 in every single one of these terms. So your GCF is going to be 7x squared. Now, once you have identified the GCF, you can factor out the GCF using this process. So the first thing you're going to do is, after identifying what the GCF is, you're going to write the GCF out front. And then everything else is going to go in parentheses next to it, and there will be hidden multiplication between your greatest common factor and the parentheses. So you're going to put the GCF out front, multiply it by a big blank set of parentheses, and all of the leftovers after you factor out the GCF are going to go in the parentheses. So then what you're going to do is you're going to go one term at a time, and you're going to remove the GCF from each term. So if the GCF was a number, then you're going to divide every single coefficient and constant by that number. If the GCF was a variable, remember, you are going to identify what the exponent on your GCF is. Then what you're going to do is, to factor out that variable GCF, you are going to subtract every single exponent in the polynomial by that power that you're factoring out. Now remember, if the GCF is a variable, the power on that GCF is going to be the lowest power of that variable that appears in the polynomial. And when you factor it out, you're going to subtract every exponent by that power. Now remember, sometimes you can have more than one GCF. So in the case of that last one we did, if you would first divide every single term by 7, and then you would subtract all the powers by 2. Also, another thing to note is you're going to see this happen a lot. Remember that anything divided by itself is 1, and anything to the power 0 is equal to 1. So you're going to see x to the power 0 come up all the time. When your exponents effectively cancel out and subtract out to 0, your variable to the power 0 is equal to 1. And remember, anything times 1 is itself. So what will eventually happen is your x to the power 0s are going to cancel out, because they're just going to become 1, and then anything times 1 is itself. Now, I will say there are going to be more factoring steps to come later. Some of these polynomials can be factored further. And if you have learned how to factor in the past, then go ahead and factor the rest of them. But we're going to get to that in another video. We're just focusing on GCFs in this video. So then we're going to take this same group of polynomials. Now that we have identified the GCF in each of them, we are now going to factor out the GCF in each of these polynomials. So starting with 8x minus 2, we already identified that the GCF here was 2. So what I'm going to do is I'm going to write 2 out front, and I'm going to put everything else in the parentheses. And then I'm going to factor out a 2 from each of these terms. And because my GCF is a variable, I am going to be dividing, my GCF is a number, excuse me. Because my GCF is a number, I'm going to be dividing each of these coefficients by 2. So 8 divided by 2 is 4. Now, if you are not factoring out a variable, you are going to leave all variables and powers alone. So since we were not factoring out a variable here, I'm going to leave that x and its exponent alone. Then I'm going to move on to the next term. Negative 2 divided by 2 is negative 1. So this is how it would factor, and this is actually fully factored. We're going to look in, you're going to learn later how to identify when something is fully factored. I'm just telling you right now, this is fully factored. Now looking at this next one on the top right, we already identified that the GCF here was an x to the power 1, and there were no numeric GCFs. So what I'm going to do is I'm going to write the variable GCF out front, multiply it by a big blank set of parentheses, and every single one of these terms is going to, we're going to put the leftovers in parentheses. So what I'm going to do is, because the power on my GCF was equal to 1, is I'm going to take each of these exponents and I am going to subtract them all by 1. Now remember, if you were not factoring out a number like factoring out this 2, you are going to leave all the coefficients completely alone. So because we're not factoring out any numbers, I'm going to leave this 2 alone. Then I'm going to subtract this exponent of 3 by 1, give me x to the power 2. And again, because you're not factoring out any numbers, you're going to leave that minus sign alone. And then we're going to do the same thing for the x squared term. We're going to take this exponent of 2 and we're going to subtract 1. That gives us x to the power 1. Then we're going to leave the plus 3 alone. And then we're going to do the same thing on this x. So 1 minus 1 will give us x to the power 0. So this is what I mean by you're going to see x to the power 0 come up all the time. And that's because when you factor out a numeric GCF, one of your terms will end up having an x to the power 0 in the end. Now remember, x to the power 0 is just equal to 1. And since 3 times 1 is just 3, we're going to write this as x times parentheses 2x squared minus x plus 3. So the x to the power 0, when you do see that happen, it's just going to completely go away and cancel out, and the variable is just going to completely cancel out because anything to the power 0 is equal to 1. So then this is going to be our final answer so far. You are going to learn how to factor stuff like this eventually. That is not this video. So then I want you guys to try the other 3 by yourselves. We've already identified the GCFs in each of these. Some of them will be numbers, some of them will be variables, and then that last one's going to have a little bit of both. So I want you guys to pause the video, try these 3, factor out the GCF in these last 3, and then resume when you are done working and ready to check your answers. All right, so looking at this next one, 9x squared plus 27x plus 3, we've already identified that the GCF here was 3. So I'm going to write the GCF out front and put the leftovers in parentheses. Now, the only thing that we are factoring out here is this numeric value 3. Because we are not factoring out a variable, we are going to leave all variables and all powers alone. So 9 divided by 3 is going to give us 3, and you're going to leave the x squared alone. Then 27 divided by 3 is positive 9, and you're going to leave the x alone. And then 3 divided by 3 is going to give you positive 1. Yes, you do need to write something here. The constant term doesn't just cancel out. The only reason that the variable here canceled out is because 3 times 1 is just 3. But in this case, since there's no variable to deal with, 3 divided by 3 is just going to give you, excuse me, 3 divided by 3 is just going to give you 1. Then looking at this next one, we have x squared plus 3x. We've already identified that the GCF was x, and the exponent on our GCF was equal to 1. So what I'm going to do is I'm going to subtract each of these exponents by 1. And since I am not factoring out any numeric values, I'm going to leave all of the coefficients completely alone. So for this first term, I'm going to subtract this exponent by 1, gives me x to the power 1. And then plus 3, we're going to leave the 3 alone. We're going to do the same thing here. 1 minus 1 gives us x to the power 0. And because x to the power 0 is just equal to 1, and 3 times 1 is just 3, your final answer is going to be x times x plus 3, and then that will be your final answer. And then for this last one, for 7x to the fourth plus 14x cubed minus 21x squared. We already identified that the GCF was 7x squared here, so I'm going to put the 7x squared out front, and I'm going to put all of the leftovers in parentheses. So what I'm going to do is for every single one of these terms, I'm going to divide all of the coefficients by 7. And then for all of the exponents, I am going to subtract all of the exponents by 2, remembering that x to the power 0 just effectively cancels out. So let's start with this first one for the 7x to the fourth. Well, 7 divided by 7 is 1, which you don't need to write the 1 in front. It's not wrong if you do. And then I'm going to take this exponent and I'm going to subtract it by 2. So 4 minus 2 is x to the power 2. Then I'm going to do the same thing for this next term, 14x cubed. So 14 divided by 7 is positive 2. And I'm going to subtract this exponent by 2. So 3 minus 2 is x to the power 1. Then I'm going to factor the GCF out of this last term. So negative 21 divided by 7 is negative 3. And then when you subtract the powers, 2 minus 2 is x to the power 0, and x to the power 0 cancels out. Now I will make the disclaimer that this can be factored further. We're just not going to do that right now. So this is all that we're doing for this video. Just keep in mind, this is not quite technically a final answer. This is just all we're doing in this particular video. So we're basically going to do the same thing for each of these next 4. We're going to figure out what the GCF is, and then we're going to factor out that GCF. Now I will say that if your terms contain more than one variable, you can have more than one variable GCF. Just remember that when your GCF is a variable, the power on that GCF is the lowest power of x that appears, or well, the lowest power of your variable, I should say. It is going to be the lowest power of your variable that appears in the polynomial. So taking a look at this first one, we've got a lot going on. Now, for numeric GCFs, when you have more than one numeric GCF, it is called a greatest common factor for a reason. So taking a look at 12 and 18. Yes, 2 goes into both 12 and 18. However, there is a larger number that also goes into both 12 and 18. So when you have more than one numeric GCF, when you have more than one common factor that's numeric, you really need to be picking the greatest common factor. You're going to be figuring out what is the largest number that goes into both of these. So the largest number that goes into both 12 and 18 is actually 6. So it's called a greatest common factor for a reason. So you're going to pick the largest number that goes into both of these, which is 6. Now they also have a lot more in common. You might also notice that they both have an a in common. And remember, anything linked with multiplication creates just one giant term. So this is all one giant term. And this is all one giant term. So because both of these terms also contain an a, there is also a variable GCF of a. Now the lowest power of a that appears in both of these is a to the power 2. So your greatest common factor is going to be a squared. Now they also both contain a b. There's a b to the power 1 here and a b to the power 2 here. So since both terms also contain a b, there is also a GCF of b, and the lowest power of b that occurs in both of them is b to the power 1. So your greatest common factor is going to be 6a squared b to the power 1. So what I'm going to do is I'm going to write my GCF out front, put the leftovers in parentheses, and I'm going to do a whole bunch of things here. I'm going to divide each of the coefficients by 6. I'm going to subtract all of the powers of a by 2, and I'm going to subtract all of the powers of b by 1. So here we go. 12 divided by 6 is 2. a to the fourth minus 2, so 4 minus 2 is a to the power 2. And then for the b terms, we have, b to the power 1 minus 1 is b to the power 0. I'll clean that up in a little bit, but let's move on to the next term. So positive 18 divided by 6 is positive 3. Now, a to the power of 2 minus 2 is going to give us a to the power 0. Then I'm going to subtract the power of b by 1, so 2 minus 1 is b to the power 1. And this c that's right here, there was no common factor of c to anything, so when that happens, you're just going to leave it alone. So I'm just going to leave that c where it is. And then yes, I am going to clean this up. So I have 6a squared b. Anything to the power 0 is just equal to 1. So since b to the power 0 is equal to 1, it effectively cancels out because 2a squared times 1 is just 2a squared. Then same thing here. A to the power 0 is equal to 1, so this will just become 3bc. And then that is going to be your final answer. So then looking at this next one here on the top right, we have a bunch of GCFs going on. So if you take a look at all of the numbers, we have 5, 35, and 10. So because all of these numbers end in either a 5 or a 0, there is a GCF of 5 here. So each of these numbers is divisible by 5. And on top of that, you might notice that there's an x to the power 3 here, x to the power 2, and x to the power 1. So because each of these terms all contains the same variable x, there is also a variable GCF. And when your GCF is a variable, the power on that GCF is the lowest power of x that appears in the polynomial. So since the lowest power of x that appears is x to the power 1, your GCF is going to be 5x to the power 1. So what I'm going to do to factor that out is I'm going to write the 5x out front, put the leftovers in parentheses. I'm going to divide every single term by 5, and I am going to subtract all of my powers by 1, remembering that anything to the power 0 cancels out. So 5 divided by 5 is 1, and then 3 minus 1 is x to the power 2. Then for the next term, negative 35 divided by 5 is negative 7. And then 2 minus 1 is x to the power 1. Then positive 10 divided by 5 is going to give us positive 2. And then 1 minus 1 is x to the power 0, and x to the power 0 cancels out. And then for reasons that you guys are going to learn later, that polynomial that's in parentheses, the x squared minus 7x plus 2, is actually not factorable. We're going to get into why later. Just letting you know now. This way you've seen it, and you've at least seen it before we get to that point. So then looking at this next one, we have 8x squared plus 2xy. So let's take a look at both of the coefficients. We have 8 and 2. Now, what is the largest number that goes into both 8 and 2? Well, they are both divisible by 2. So there is a numeric GCF of 2. And both of these terms do contain an x in it, and the lowest power of x that appears between the two of these is x to the power 1. So 2x to the power 1 is going to be our GCF. Now, because the second term has a y, but the first one does not, there is not a greatest common factor of y. So y is not a common factor because not every single term has y in common. So that y is just going to stay there on that last term, and that is going to be it. So what I'm going to do is I'm going to put the 2x out front, put the leftovers in parentheses, and I'm going to divide all of the numbers by 2, and I'm going to subtract all of the powers by 1. So here we go. 8 divided by 2 is going to give us 4, and then 2 minus 1 is x to the power 1. Then positive 2 divided by 2 is positive 1. And then 1 minus 1 is x to the power 0, which cancels out. And then that leaves you with y. So both the 2 and the x canceled out here because they both became 1s. And then 1 times y is just y. So then this is going to be your final answer, and it is actually fully factored. So then looking at this last one, we have n cubed minus 5n squared plus 2n. So not all of the numbers are divisible by the same thing. In fact, all of the coefficients are prime numbers because we have 1, -5, and 2. So there's no numeric GCF here. But each of these terms does contain the same variable n. So because every single term contains an n, the GCF is going to be n, and because the lowest power of n is 1, your GCF is n to the power 1. So what I'm going to do is I'm going to write the GCF n out front. I'm going to put the leftovers in parentheses, and I'm going to subtract all of the powers by 1. Now remember, because we are not factoring out any numbers, you're going to leave all of the coefficients alone. So you're going to leave this leading coefficient of 1 alone, and then 3 minus 1 is n to the power 2. Then you're going to leave the negative 5 alone, and then 2 minus 1 is n to the power 1. Then for the last term, you're going to leave the plus 2 alone, and then 1 minus 1 is n to the power 0, and n to the power 0 cancels out. And then this would be your final answer, because n squared minus 5n plus 2 is not factorable, so that is going to be your final answer. Now if you take a look at these two terms are going to lead us into the next part of this video lecture, which is a process called factoring by grouping. Remember that anything that is linked with multiplication is all technically considered one term. So this 4x times 3x minus 2 is technically all one giant term. The minus sign is what separates them into two terms, and then 7 times parentheses 3x minus 2 is also one giant term. So if you look on either side of that minus sign, a GCF is anything that the two terms have in common. So there is something that these two terms that I have underlined have in common. What do they have in common? Well, they have this parentheses 3x minus 2 in common. So what I'm going to do is I am going to factor out that greatest common factor like I normally would. So I'm going to factor out that parentheses 3x minus 2, write it out front, and put the leftovers in parentheses. So in this first term here, after you factor out the 3x minus 2, what's left over? Well, what's left over in that first term is going to be 4x. So I'm going to put the leftovers here in parentheses. Then in the second term, after you remove the 3x minus 2, what's left over? Well, what's left over is that minus 7, so I'm going to put the leftovers here in parentheses. So that process there of identifying a GCF, which might be a parenthesis with a binomial in it, is the cornerstone of a process called factoring by grouping. So I will say that a lot of polynomials have different techniques used to factor them, and we're going to be going over a ton of different factoring techniques throughout this chapter. One factoring technique that relies completely on finding and factoring out greatest common factors is a process called factoring by grouping. So this is most often used when the polynomial has exactly 4 terms. So any polynomial that has exactly 4 terms may be eligible to be factored by grouping. So it is most often used for factoring polynomials of degree 3, which are also called cubics. But you can also use this process for factoring quadratics, which are polynomials of degree 2. We're going to get more into that as we go, but we're going to be using this when your polynomial contains 4 terms. So here's what factoring by grouping involves. You are going to split the polynomial into 2 groups of 2 terms. And you're going to treat each group separately, at least to start, before you put it all together later. Then what you're going to do is you're going to look at each group one at a time, and you're going to factor out the greatest common factor of each group, if there is one. If there is no greatest common factor, then you can at least factor out a 1 just to kind of go through the steps and go through the motions and the process. Then you will end up with a situation like this. Well, you'll have 2 giant terms linked with multiplication, and each of those groups is then going to have a GCF between them, like in the fashion of that parentheses 3x minus 2. So then when you have each group has a GCF between them, you're going to factor this out. Now sometimes that will be the end of it, and then that will be fully factored and you're done. However, you might be able to factor it further, and we're going to do more of that later. So do be prepared for factoring by grouping to come back up when you have learned other factoring techniques that could help you finish factoring some of these polynomials. So a polynomial like x cubed minus 4x squared plus 2x minus 8 is a polynomial that is eligible to be factored by grouping, mostly because it has exactly 4 terms. So at least for this first example, I'm going to try and color coordinate it. So I apologize for the amount of menus that are going to pop up here, but I'm going to try and color coordinate this as best I can, at least for this first one. And then after this, I don't think color coordinating is going to be really feasible here. So I'm going to group this into 2 groups of 2 terms. I'm going to put these first 2 terms in a group. Hopefully this won't crash my PC. And then I'm going to put these last 2 terms in a group, and I'm going to take that plus sign with it because a number always takes the sign to its left. So then I'm going to focus on the first group, which I have underlined here in red. So I'm going to identify the greatest common factor just between these first 2 terms, so just between x cubed and minus 4x squared. Now there's no numeric GCF between these, but the highest power of x that appears just between these first 2 terms is x to the power 2. So I'm going to factor in x to the power 2 just out of this first group. So what I'm going to do is I'm going to put the x squared out front, write the leftovers in parentheses, and all I am going to do is factor out an x squared only out of the first 2 terms. So which means I'm going to take each of these exponents and I'm going to subtract them all by 2. And because we are not factoring out any numbers, I'm going to leave all the coefficients alone. So I'm going to leave the leading coefficient of 1 alone, and then 3 minus 2 is x to the power 1. Then I'm going to leave that minus 4 alone, and then 2 minus 2 is x to the power 0, and x to the power 0 cancels out. So then I'm going to do the same thing for the next group. So now I'm going to take the next group, this positive 2x and this minus 8, and I am going to identify and factor out the greatest common factor between those. So what is the greatest common factor between just 2x and minus 8? Well, the only thing that 2x and minus 8 have in common is 2. And since it's positive, I do need to separate these with something, so I'm going to factor out a positive 2 just out of the second group. So I'm going to put the GCF out front, put the leftovers in parentheses, and I'm going to factor out a positive 2 just out of those last 2 terms. So 2 divided by 2 is 1, and you're going to leave the x alone. Then negative 8 divided by 2 is negative 4. Now if you take a look at these, remember this is linked with multiplication, so this is all one giant term. And this is linked with multiplication, so this is all one giant term, and they are separated by that plus sign. So looking at those 2 terms that I have underlined, what do they have in common? Well, both of these terms have this parentheses x minus 4 in common. So I'm going to factor out the parentheses x minus 4 like I would any other GCF. And I'm going to put the leftovers in parentheses. And the leftovers are going to be what is left when you remove the x minus 4 out of that term. So in the first term, when you have removed the x minus 4, what is left over in that first term? Well, that first term, there is going to be an x squared left over. Then for the second group, for the second term, when you remove the x minus 4, what is left over? Well, there is a plus 2 left over when you remove the x minus 4, so I'm going to put the plus 2 next. And then for reasons that you're going to learn later, x squared plus 2 is actually not factorable, so this is actually fully factored. So we have successfully factored really our first polynomial. We have taken this polynomial here and we have written it as the product of 2 other polynomials. We have written it as the product of the polynomials x minus 4 and the polynomial x squared minus 2. That is what factoring is. Factoring is taking a larger polynomial and writing it as the product of two smaller polynomials. And that's exactly what we've done here. So we're going to do the same thing for this next one. So this next one, there are 4 terms here. So it is eligible to at least attempt to factor it by grouping because there's 4 terms. So I'm not going to color coordinate this here because I'm sure that was annoying going through all those menus, but yeah, I like color coordinating at least at first so you can see what is coming out of where. But we're going to factor this next one by grouping. So to factor it by grouping, I'm going to separate this into 2 groups of 2. So I'm going to put the first 2 terms into a group, and I'm going to put the last 2 terms in a group, taking the plus sign with that 3. Then I'm going to identify and factor out the GCF out of each group. Now, if you have more than one GCF in a group, you're going to factor out both of them. So I'm looking at the 2x cubed minus 10x squared. If you take a look at 2 and 10, 2 and 10 are both divisible by 2. And there's an x to the power 3 in the first term and an x to the power 2 in the second term. So because you're only factoring out the GCF out of these first 2 terms, the greatest common factor between x cubed and x squared is going to give you x squared. So I'm going to factor out a 2x squared only out of the first group, so only out of those first 2 terms. So I'm going to divide all of the numbers by 2, and I'm going to subtract all of the powers by 2. So here we go. 2 divided by 2 gives you 1, and then 3 minus 2 is x to the power 1. Then negative 10 divided by 2 is negative 5. Negative 5. And then 2 minus 2 is x to the power 0, and x to the power 0 cancels out. Then I'm going to do the same thing in the next group. So I'm going to take the next group, 3x minus 15, and I'm going to identify and factor out the GCF out of the last 2 terms. So the only common factor between the last 2 terms is both of these numbers are divisible by 3. And I'm going to factor out a positive 3, and I need to separate them with a plus sign. So I'm going to factor out a positive 3 only out of the last 2 terms, and because I am not factoring out any variables, I'm going to leave this x and its exponent completely alone. So 3 divided by 3 is 1, and you're going to leave the x alone. Then negative 15 divided by 3 is negative 5. Then from here, remember this multiplication makes this all one giant term, and this multiplication makes this all one giant term. So what do those 2 terms that are on either side of that plus sign have in common? Well, both of those terms have a parentheses x minus 5 in common, so I'm going to factor out the x minus 5 and put the leftovers in parentheses. So when I remove the x minus 5 out of this first term, there is a 2x squared left over. Then when I remove the x minus 5 out of the second term, there is a positive 3 left over. And then this is going to be your final answer. 2x squared plus 3 is not factorable, so that is actually going to be your final answer. So I want you guys to try that for yourself. This one is a little bit different. This is not a cubic. The highest power here is actually 2, but it's going to follow basically the same process. You're going to split this up into 2 groups of 2, and you're going to factor it by grouping. So I want you guys to try this one, factor this polynomial here by grouping, and then resume the video, pause the video, and then resume it when you are done working and ready to check your answer. All right, so for this next one, we're going to split this up into 2 groups of 2. So we're going to put these first 2 terms into a group. Then I'm going to put these last 2 terms into a group. And then I'm going to identify and factor out the GCF out of each group. So taking a look at 3x squared plus 6x. Well, both 3 and 6 are divisible by 3. And there is an x in each of these first two terms, so there is also a GCF of a variable. And since the lowest power of x that appears just in the first group is 1, there's going to be a common factor of 3x to the power 1. So just out of the first two terms, I'm going to divide both of the numbers by 3, and I'm going to subtract all of the powers by 1, keeping in mind that x to the power 0 cancels out. So here we go. 3 divided by 3 is 1, and then 2 minus 1 is x to the power 1. Then positive 6 divided by 3 is positive 2. And then 1 minus 1 is x to the power 0, and x to the power 0 cancels out. So then I'm going to do the same thing for the next group. So between 4x and 8, I'm going to identify the greatest common factor. Now, yes, both 4 and 8 are divisible by 2. That is not the greatest common factor. There is a larger number that goes into both 4 and 8. The larger number that goes into both 4 and 8 is 4. So I'm going to factor out a positive 4 just out of the last two terms. And because I'm not factoring out any variables, I'm going to leave this x and its exponent completely alone. So 4 divided by 4 is 1, and you're going to leave the x alone. Then 8 divided by 4 is positive 2. So now, taking a look at both of these as a whole, we have two giant terms. What do both of those giant terms have in common? They both have an x plus 2 in common. So I'm going to factor out the parentheses x plus 2 and put the leftovers in another set of parentheses. So when you remove an x plus 2 out of the first group, you are left with 3x. Then when you remove an x plus 2 out of the second group, you are left with plus 4. And this is actually fully factored, and that is actually going to be your final answer. So we're going to do the same basic thing for this next one. I'm going to split this up into two groups of 2. So I'm going to put these first two terms into a group and these last two terms into a group. Now remember, if at any point in this video you do want to attempt a problem before I go over it, just feel free to pause the video and resume when you are done working. But I'm going to go through this one with you guys. So taking a look at these first two terms, I have x cubed minus 6x squared. Now, unfortunately, there's no numeric GCF between the first two terms, but both of the first two terms have the same variable. So there is going to be a variable GCF, and the power on that GCF is going to be the lowest power of x that appears between the first two terms, which is x to the power 2. So I'm going to factor in x to the power 2 out of just the first two terms, and because I'm not factoring out any numbers, I'm going to leave all of the coefficients alone. So 3 minus 2 is x to the power 1. Then we're going to leave the minus 6 alone, and then 2 minus 2 is x to the power 0, and x to the power 0 cancels out. Then taking a look at the last two terms, this plus 10x minus 60. Again, if you have more than one common factor, you're going to pick the largest common factor. So the largest number that goes into both 10 and 60 is positive 10. So I'm going to factor a 10 out of the last two terms, leaving this variable and its exponent completely alone. So 10 divided by 10 is 1, and you're going to leave the x alone. Then negative 60 divided by 10 is negative 6. Then from here, you're going to look at this as a whole. So this is one giant term, and this is one giant term. What do both of those terms now have in common? They have in parentheses x minus 6 in common. So I'm going to write my GCF out front, and I'm going to put the leftovers in parentheses. So when you remove the x minus 6 out of this first term, you are left with x squared. Then when you remove an x minus 6 out of the second term, you are left with plus 10. And then from here, that is going to actually be it. X squared plus 10 is actually not factorable, so that is going to be your final answer. Now, I will say, I don't know, you probably hadn't noticed at this point, but in every single one of these that we did, this third term right here was always positive in these last few examples that we did. If that third term is negative, What you will need to do is, in order to get these two parentheses in this step to match, is you will need to factor a negative GCF out of the second group. And if there's no other GCFs in the second group, at the very least, you're going to be factoring out a -1. Because if you notice, in this step here, the only reason that we are able to arrive at this last final answer is because these two parentheses are exactly the same, and they are exactly identical in every way. The two parentheses being exactly the same in every way is what makes them a greatest common factor. If those two parentheses are not exactly the same, if they differ even by a sign, they're not a GCF and you can't factor them out. So it is extremely important that you make sure that you are doing this in such a way that the two parentheses at this step here are exactly the same and can be factored out. So I'm going to go about this like I normally would, just keeping in mind if the third term is negative, you're going to factor a negative GCF out of the second group. So I'm going to split this into two groups of two terms. I'm going to put these first two terms into a group, and I'm going to put these last two terms into a group. And I'm going to factor out the GCF out of each group. So the greatest common factor between x cubed and 4x squared is going to be x squared. So I'm going to factor in x squared out of the first two terms. So 3 minus 2 is x to the power 1. Leave the plus 4 alone, and then 2 minus 2 is x to the power 0, and x to the power 0 cancels out. Now, because this third term right there is negative, what you will need to do is we need to factor a negative GCF out of the second group. So we're at least going to be factoring out some sort of negative out of the last two terms. And there are other GCFs. The largest number that goes into both 4 and 16 is 4. So I'm going to factor a -4 out of the last two terms. So I'm going to be dividing the last two terms both by -4. So -4 divided by -4 is +1, and you're going to leave the x alone. Then -16 divided by -4 is +4. So you might have noticed that if you hadn't factored out that negative, this second set of parentheses would have been a -x minus 4, which is not the exact same. So, but now that we have factored out the -4, if you look between these two terms, they now have a matching set of parentheses. They have an x plus 4 here and an x plus 4 here. So because these two parentheses match, they are considered a common factor, so you can factor out the parentheses x plus 4. And then we're going to put the leftovers in another set of parentheses. So when we remove the x plus 4 out of the first group, there is an x squared left over. Then when you remove the x plus 4 out of the second group, there is a -4 left over. Now I will make the disclaimer that this x squared minus 4 can be factored further. We're just not going to do that in this video because that's way too much to do at this point. So we're going to do that later. So when you guys learn how to factor things like x squared minus 4, you can keep going and you can keep factoring this. But for now, that's all we're going to do. So we're going to call this our final answer for now. So that is it on greatest common factors and the process of factoring by grouping, which is a factoring process that relies entirely on GCFs. So in the next video, we're going to start learning more factoring processes, and we're going to keep learning more factoring processes until we basically cover them all. So stay tuned for those videos. Thank you all very much for watching, and I will see you in the next video. Bye-bye.